Okay, so question 9, paper 3. We've got a sample space diagram. Always find out what the rule is here. Okay, so the score for the game, so you're always looking for the score, is the product of the two numbers. So product means multiply. For example, it shows us here 3 times 4, which is 12. So you go across, 6 times 1 is 6. 6 times 3 is going to give us 18 here. 6 times 5 is going to give us 30. 6 times 7 is going to give us 42. Down here, 8 times 1 is 8. 8 times 3 is 24. 8 times 5 is 40. 8 times 7 is 56. And there's that filled in. Okay, now we can move on down. A player wins a prize by getting a score of 12 or less. Costs ATP. The prize is £1.50. 160 people play, find the profit. Always asking to find the profit. So, score of 12 or less. So we need to go up here and count out the probability of getting 12 or less. So we've got 1, 2, 3, 4, 5, 6, 7. These ones here are the 12 or less. So that's 7 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 options. Probability of getting 12 or less is 7 out of 16. If 160 people play, first thing to work out profit, you should always work out how much do they take. So 160 people play and they each pay £0.80. If we work that out, that is going to be £128 they make. Okay. Now we want to work out how many people win. We know that 7/16 win out of 160. So to work that out, I would do 160 divided by 16 and times by 7. Divide by the bottom, times by the top. So we end up with 10 times 7 is 70 people win. Divide by the bottom, times by the top. So we know that 70 people win £1.50, which is £105 that they have to pay out to people who win. So they took £128, they had to pay out 105 in winnings, so they make £23. Question 10. Okay, so do your data in the table to draw a conversion graph. Here's conversion is you can go between one unit and another. So be careful with the scales on these and careful which way you go. So miles are on the bottom, so we'll go across to 8 and we're going up to 7, which is 1, 2, 3, 4, 5. So it's right in the middle of these two. 1, 2, and it's going to be in the middle there. Then we're going across 16 up 14. So across 16 and we're going to go up to 14 there. And the last one across 23 up 20. So across 22, 23 is right in the middle. And we're going to go up to 20, which is there. Okay. And then if you've plotted them correctly, they should join up into a straight line. Okay, which you should extend all the way across. Right then. Question, find an estimate for 50 nautical miles. Now then, obviously you can see this nautical miles doesn't go up to 50. So I go up to 10 and read across and see what that reads down as. Okay, so 10 nautical equals approximately 10, 11's there, so approximately 11.5. So 50 nautical. You want to make this 5 times bigger. So you want to times by 5, which is going to give us 57.5 miles. Question 11. Here are two parallelograms identical and they've shown us the corners of the vertices, which means corners. Now you want to find what A, B and C is, the points here. Now A we can see is directly below this one. It's directly below, we know it's going to have the same x coordinate because it's gone across the same. So we know that's going to have 11. Okay. Now y is obviously different to this coordinate, but y going up or down is the same as this one here. That's going to be a -1. B going across hasn't gone across the same as any other because we haven't found C yet, but we know that that is 19 there. Okay, and we know that from there to there is a jump of 11 to 13, a jump of 2. So this is going to have the same jump. It's going to go 19, jump across 2, that's 2 there. So that is going to be 21. You see the jump is 2 there, so the jump is going to be 2 going across there. Now height-wise, it's at the same height as this one, so it's going to be at a height of 9. You can see it's the same height. C then, going across, it's going to go the same across as B. Going up, so on the same level as this one, we don't know what that is, but this one here has gone down from 7 to -1. So we know that's gone down 8. So we know that this one needs to go down 8 as well. So 9 take away 8, that means that point is at coordinate 1. And check that they seem reasonable answers. Question 12. 2 train timetables. Okay. From Swansea to Bristol Parkway. So you start at Swansea, go to Bristol Parkway, they get on at Bristol Parkway again and get off at Sheffield. So Sophie gets on the 10:55, so she gets on this, these are 4 different buses, 4 different trains, sorry. And she gets on this train from Swansea, but she doesn't get on until Bridgend. This is where she gets on. She's on this train. When they say from Swansea, they just mean this train. That is just telling you which train to look at. And she gets on at Bridgend. She gets on this very one here. And she gets on at 11:25. And she gets off at Newport 12:08. Okay, so although it mentions Swansea, it just means to show you which column to go in. So 11:25 to 12:08, which is going to be 43 minutes. David lives in Port Talbot and needs to get to Birmingham by 3:30 in the afternoon. What's the latest train you can catch from Port Talbot? So these are ones from Port Talbot, and he wants to get to Birmingham by 3:30. So we need to look at the Birmingham trains and see which ones get there by 3:30. This one does. Okay. So we need to look back up what times you need to get on at Port Talbot. You need to get on Port Talbot at 11:47. Then it says, how long is he going to wait in Bristol Parkway? So we'll get to Bristol Parkway at 12:59. Okay. And you need to get his next train at 13:40, which is just 41 minutes. Okay. On the last day he travelled, owing to signal problems, all Swansea trains were 10 minutes late, arriving at Bristol Parkway, and trains to Sheffield were 15 minutes late, leaving Bristol Parkway. Given the trains kept in normal speed, what time did David arrive in Birmingham? So we said that David got on this one here. Okay, so we know that he arrived in Bristol Parkway 10 minutes late, so he arrived in Bristol Parkway at 13:50. Sorry, he arrived in Bristol Parkway not at 12:59, but he arrived in Bristol Parkway at 11:09. So that was still fine. He could still catch this one here. But it says the trains to Sheffield were 15 minutes late leaving. So instead of leaving at 13:40, he left 15 minutes late. So this train here is going to arrive 15 minutes late. So you're going to have the arrival of that train. It meant to arrive at 14:56. It was 15 minutes late. So it arrives at 15:11. So the train arrived 15 minutes late. Okay, specify positive prime factors in index form. Positive prime factors, remember you put 140 on this side and we start with our prime factors. So we start with dividing by 2. 140 divided by 2 is 70. Then try 2 again if you can do it, that is 35. Can we do 2 again? No. Can we do 3? No. So next one we try is 5. How many 5s in 35? 7. Can we do 5? No. So we go up to 7. How many 7s in 7? 1. So we have an index form, so 2 squared times 5 times 7, which is 2 times 2 times 5 times 7. Number 126 can be expressed as this. They've already worked out. Use this fact and your answer to A to write down the highest common factor. So we're going to need to use our Venn diagrams. Oops, sorry, I haven't done those quite big enough. Do them down here. Make sure you need a nice overlap. So we're going to have 126 and we're going to have 140. So we need to look at our two things. So 126 from up here was 2 squared times 5 times 7. 140 was 2 times 3 squared times 7. And we look for things that are common. Now what I do, first off, to help you out a little bit more, is write this out without the indices. So 2 times 2 times 5 times 7. And 2 times 3 times 3 times 7. So we've got one common pair there. I can go in the middle, 2. We have another common pair there, that's a 7, can go in the middle. And then 126, we have a 2 and a 5 left. 140, we have a 3 and a 3. So things that are common, highest common factor, we take the numbers in the middle. So we do the 2 times the 7, which is going to give us 14.